So I think I'm recording. I gave you some practice problems, I think around 10 or 12 of them, that is just finding the domain from an equation. And these first six all had radicals, all had square roots. And I can't take the square root of a negative number. So this expression x plus 6, I can take the square root of 0, but I need it to be positive. So I need this x plus 6 to be 0 or positive, meaning that it can't be negative, that it has to be greater than or equal to 0. To solve this inequality, we want values in the domain that are bigger than negative 6. If this is negative 6, to the left is negative 7, to the right is negative 5. Values that are larger, that are bigger than, greater than, or equal to negative 6 are values to the right, because if I put my variable on the left, the arrow will point in which direction I need to shade. I need to describe this as my domain. So my domain is negative 6 to positive infinity, which makes sense to me because if I plug in a negative 7 plus 6 is a negative number. I can't take the square root of a negative number. But if I plug in negative 6, I get 0. Taking the square root of 0 is fine. If I plug in negative 5, I get 1, and taking the square root of positive 1 is fine. So all these, this is my domain for this problem. Same idea in number 2. Now many people were asking me, what about this plus 1? What about this 1/2, this 4? Those are vertical transformations. They're affecting the graph. This is a vertical shrink. This is a shifting the graph up. It's changing the range, not the domain. And I'm not going to have you find the range from equations. I'm only having you find the range if I give you the graph. So here, this x minus 2, it's underneath the square root. It has to be 0 or positive. X has to be bigger than positive 2 on a number line. If I have 1, 2, 3, values that are bigger than 2 are to the right of 2. Values that are smaller than 2, like 1 or 0, plug in 1. 1 minus 2 is negative 1. I can't take the square root of negative 1. Plug in 0. I can't. 0 minus 2 is negative 2. I can't take the square root of a negative number. Those are not in the domain. So my domain is from 2 to infinity. So here, well, this looks to be the same as problem 1, right? Yeah. So the 3/5 is affecting the range. It's a vertical shrink. The plus 1 is lifting up 1. That's up and down and affecting the range. The x plus 6, that's what I needed to be greater than or equal to 0, just like in problem 1. So this answer for number 3 and the answer for number 1, they have the same domain. Now they're not going to have the same range, but remember, I would give you the graph to find the range to help you, probably the equation and the graph, or at least the graph. So x plus 2, did we already have x plus 2? No, we had x minus 2. So this x plus 2, it needs to be 0 or positive. It cannot be negative. If I subtract 2 from each side, I need the values in the domain to be at least negative 2. Negative 3, that's going to cause that to be negative. I can't take the square root of a negative number. But all of these values that are larger than negative 2, including negative 2, those are fine. I'll get a related y value. If I plug in negative 2, if x is negative 2, then y is positive 2, because negative 2 plus 2 gives me 0. The square root of 0 is 0. 2 plus 0 is 2. So my domain, negative 2, and the arrow shaded out to positive infinity. X minus 4. It can't be negative. It's got to be 0 or positive. Add 4 to both sides. Make a sketch on my number line. Values that are greater than or equal to 4 to the right of 4. I include 4 because 4 minus 4 is 0. 5 times 0 is 0. 0 minus 4 is a negative 4. If you put in 4, it's related to negative 4. It's in the domain. And let's shade in my arrow. So my domain, it starts at 4 all the way out to positive infinity. Any of those values you plug into this equation and you're going to get a related y value. Plug in something like 3 and 3 minus 4 is negative 1. I can't take the square root of negative 1, so how am I going to multiply it by 5 and subtract 4? There's not going to be a y value. 3 is not related to any y value, so 3 can't be in the domain. X minus 4. See, I've already forgotten. Have we already done x minus 4? Let's look real quick. There it is. I just did it. Gosh, memory of a frog. I blink and I forget. All right. My problem, not yours, right? All right. So it's the same work. X minus 4 has to be 0 or positive. The 5 and the negative 2, they're affecting the range. Vertical stretch, down 2, up and down and vertical, that's the range. That's the y coordinates. The only thing affecting the x coordinates is this shift that's to the right 4 units of my parent function. It's the square root of x. My domain for this problem is 4 to infinity. Now here, on the quiz, I'll use the variable x, and it'll either be equal to y or f of x, either using function notation or x and y notation. But the idea here is the same. We don't have any square roots, but we can't divide by 0. This denominator can't be 0. Well, this is a quadratic equation. You can use the quadratic formula if you want. That's a little bit time consuming. Or you can look at it and say, well, I can factor this. If both of these are divisible by the number 8, and both have a k in them. So when I factor out what's common, what I'm doing here, let's even write it out more to really illustrate. I'm looking at 8 and I'm looking at k squared as k times k. And I'm looking at 24 as 3 times 8 times k. And I'm noticing that I have an 8k in this term and I have an 8k in this term. So you factor out, you pull out this 8k from each term. You write it once out here as multiplication, and what's left, what did not factor, was this factor of k and this factor of negative 3. So now if two numbers multiply together to give you 0, one of them or both of them has to be 0. So either 8 times k is equal to 0, well that only happens when k is 0, or if this product is 0, k minus 3 has to be 0. Well, that only happens when k is 3. 3 minus 3 is 0. So these are the solutions to this denominator being 0, and we actually do not want that to happen, because if you try to plug in k equals 0, there's not a related y value. If you try to plug in k equals 3, you have division by 0. We know it satisfies this equation. It makes this denominator 0. So those were the only two solutions to that equation, that denominator equal to 0. So it's the only two things that we have to throw out of the domain. All of the other numbers are fine. None of these other numbers cause us division by 0. Well, it's too many to list. I have infinitely many numbers there. So this arrow is shaded, so that's representing that it's going all the way to negative infinity up to 0, and 0 is an open hole, so we exclude it. We have an open parenthesis here, not a bracket. Since we have a second interval, we have a union. Well, the second interval is between 0 and 3, and it doesn't include the endpoints. And we have a third interval, so we need a union, and it's 3 to infinity, but it's not including 3. There's my domain for this guy. What about number 8? Well, I don't see any radicals, but I do see a variable in the denominator. Tomorrow it'll be x, or whenever, when you take the quiz, it won't be r, it'll be x, but that shouldn't cause any problems. Set this equal to 0. Add 6 to both sides. You can probably see by inspection that 2 times 3 is 6, and that 6 minus 6 is 0, but divide both sides by 2. And you see that 3 is the solution to this equation. 3 causes this denominator to be 0. We want to avoid that. So really, we want r to not equal 3, to tell you the truth. And I wouldn't lie to you. You're listening to the guy who invented the wave at college football stadiums. Nobody believes me. So my domain, well, this left interval here is negative infinity to positive 3, excluding 3, or you're on this right interval, which is 3 to positive infinity. So there's my domain. About this next one. Again, I see a variable in the denominator, and again, I don't have any radicals, so this guy I want to avoid it equaling 0. Well, I can't just look at this and figure out what values cause it to be 0. I have to either use the quadratic formula or see it in factored form to figure it out. So in factored form, two numbers that multiply to give me 14 but add up to 9 are 2 and 7. So I've got r plus 7, r plus 2. So if this product is 0, it has to be that r plus 7 equals 0 or that r plus 2 equals 0. That's the only way to have 5 times 5 is not 0. That's the only way to get 0 is to have one of them or both of them be 0. Well, they both can't be at the same time. But if you have negative 7, you got negative 7 plus 7, that's 0. Or if you had negative 2, that's 0. We need to avoid that because really we want this to never equal 0. Negative 7 is smaller than negative 2. So on my number line, I have negative 7. Over here to the right somewhere is negative 2. All of the numbers that are not negative 7 or negative 2, they're in my domain. So I need to use interval notation to describe this domain. Too many numbers to list. So the only way to describe it we have is set builder notation or interval notation. Let's use interval notation. From negative infinity up to negative 7. Or if you're between negative 7 and negative 2. Or if you're strictly bigger than negative 2. Because you won't get a y value if you plug in negative 7. You'll have a 0 in the denominator. Negative 7 needs to be related to some number in the range. If it's not, then it's not in the domain. Every number in the domain is related to some number in the range. Same idea here. So it's kind of getting to be repeat. You can't take the square root of a negative number and you can't divide by 0. So I like my leading coefficients to be a positive 1. So I'm going to multiply both sides of this equation by negative 1, which is going to change the sign of every term. And the opposite of 0 is 0. When I change the sign of 0, 0 doesn't have a sign. It's neutral. So now when I factor this, I need two numbers that when multiplied together are positive, but when added are negative. Well, that means that these are going to be both negative numbers. They have to multiply to give me positive 24, but add to give me negative 10. So 4 and 6 do the job. Minus 4 and minus 6 do the job. And so 4 minus 4 would give you 0. 6 minus 6 would give you 0. But remember, we don't want this to happen. We do not want this to be 0. Therefore, we do not want 4 to be in the domain. We do not want 6 to be in the domain because they won't be related to any output, to any y value. This is how you get y values, is through this fraction, through this equation. by plugging in numbers in the numerator and that same number in the denominator and calculating the arithmetic. Well, you're not going to get a y value if you have 4 or if you have 6. Now, any of these other numbers are fine. They're not going to cause division by 0. So we have to describe them. Well, we have a way to describe them using this interval notation. The arrow shaded, negative infinity, up to 4, between 4 and 6. So since I have a break in my graph, I need a union. And then 4 to 6, I'm excluding 6. I don't want a bracket there. That would be a solid dot. And 6 to infinity. All right. Hey, we're getting close to the finish. So if this guy's equal to y, this denominator, I can't let it be 0, but I can't see that by inspection, so I have to temporarily let it equal 0. I either need to use the quadratic formula or to factor it. Two numbers that add up to 15 are 7 and 8. They multiply together to give me 56, or at least I hope they do. Negative 8 plus positive 8 gives me 0. Negative 7 plus positive 7 gives me 0. Negative 8 is smaller to the left of negative 7. I need to exclude these, but all the other numbers, they don't satisfy this equation. They do not cause this to equal 0. So I need to describe what I've just shaded in there. And since it needs to be in written form, I can't just tell people. I guess if I was face to face, I could tell you, hey, don't use negative 8 and don't use negative 7 in the domain. Exclude those two values. So that's how I want to write my answer. Now for your favorite problem, the last problem, or at least I think it's the last problem. Again, the denominator can't be 0. I can't see that by inspection, so I need to set it equal to 0, figure out what the solutions are, and then avoid this equaling 0. So if I factor this, I need two numbers that multiply together to give me a negative 14. Well, one's got to be positive and one's got to be negative. I need the larger one to be positive because I have a positive middle term. So I need this to be 7 and this to be minus 2, right? This gives me negative 7 plus positive 7 is 0. And positive 2 minus a positive 2 minus 2, that's 0. So we need to throw out negative 7. We need to throw out positive 2. So my domain has three parts to it: negative infinity to negative 7, or from negative 7 to positive 2. Oops. Sign errors are the enemy. Ta-da! There we go. There's our final answer. Hope that helps, and I'll talk to you tomorrow.